All right. Well, welcome everyone who is here. Hopefully you're in the right spot. This is the Computer Science and Data Science Major Exploration virtual event. Super excited to have y'all here. In this welcome slide, you might notice, because we'll give maybe 30 seconds, 30 Mississippis or so for folks to join. We do have a department newsletter or mailer, an e-newsletter. So the Z link on the bottom of this slide, that's z.umn.edu/csci-mail. If you go to that link, you can sign up to receive the e-newsletter. As you might be aware, computer science and data science are two large programs in a large department, excuse me. And so we try to be communicative and transparent, and the mailer is one of the ways that we do that. So that can be a great way to stay on top of the happenings in our department. But without further ado, I am going to click to the next slide and I will give our faculty participants who are here a chance to introduce themselves.
Yes, hello. So this is Mats Heimdal. I'm the head of the Department of Computer Science. And I will say a few words in a second here about just welcome you to the department and let you know a little bit about what computer science is about. Jaideep?
Hi, I'm Jaideep Srivastava. I'm a professor in the Computer Science Engineering Department, and I'm also the Director of Undergraduate Studies for the Data Science Bachelor of Science program. And I'll introduce the program to you.
Hi there, I'm Nick Hopper. I'm also a professor in the Computer Science Department, and I'm the Director of Undergraduate Studies for the Computer Science degrees in our department.
So Mats again here, I'm kicking this off. So first I want to welcome all of you, and I see there are a lot of, it's like 250 students here for this event. So welcome you all to the College of Science and Engineering, which is not to be confused with CS and E, which is Computer Science and Engineering. I know it's very confusing. There's a long history behind that I'm not going to get into, but there's a lot of cool stuff happening in the college, right? We have all the engineering departments here. We have all the hard sciences like physics and chemistry and earth sciences, mathematics. So there's a lot of excitement, a lot of exciting things happening here. But I personally, and now we can switch slide, think the most exciting thing and most interesting of all is computer science and engineering. Computers are fascinating, and programming them is also fascinating. And even if you don't find computers and computing itself super exciting, switch slide, it's an interesting field to be in because computing is everywhere, right? It doesn't matter what industry segment or what kind of research or what you want to get involved in, it's going to involve computing. It's going to involve computer science, data science, or software engineering one way or another. Whether you want to build cars or airplanes or rockets or TVs or medical devices or sell stuff online or connect people or do pretty much anything else. Stock trading, nobody trades stock anymore. Computers trade stocks, right? Doesn't matter what you're going to get involved in, it's going to involve computing. And I think that's what makes computing so exciting, because you can work pretty much anywhere. You can work in any segment of the industry, and the opportunities are frankly endless, right? So that puts us, computer science and engineering, in the middle of pretty much everything that goes on in the world. And that is absolutely fascinating. Next. So who are we over here in computer science? Now there are a little bit of animations here, so you can click away, do one. The traditional view, of course, of us computer science nerds is the computer science nerd, which is actually not a derogatory term. We're all proud nerds. You can click. But that's not all we are. And when you're going to discover when you join computer science that it's not a solitary endeavor. Being a professional programmer, professional software engineer, professional data scientist, it's going to involve working with other people a lot. Communication, teamwork, the social skills that you need, all of that is going to be absolutely crucial for you moving forward in this profession. You do not work alone. We're building software to help other people and understanding their needs, their desires, how they're going to work with the software, what the ethical concerns are, being involved in the software development, so on and so forth, is really going to be crucial for your career. So being a computer scientist is going to be a very social and team-oriented experience, because that's what you're going to be doing. So if you're afraid that you're going to end up as solitary programming, sitting locked away in a cubicle somewhere, that's just not going to happen. You're going to be parts of teams, you're going to be talking a lot to people, and you're going to have a lot of fun if you join us here in computer science. Next. So that's all I'm going to say about it, really. Feel free to reach out to me or our advising team to get more information. But I just want to welcome you first to the College of Science and Engineering, and then preemptively, since you're all going to come to computer science, welcome you to computer science. And I hope to get a chance to see you in a welcome to the major event and other kinds of events here over the next few years. So that's all I'm going to say. I'm going to hand it over to Nick, I believe, to talk about our computer science program in a little bit more detail. So thank you very much and welcome.
Thanks, Mats. Really briefly too, just because I've seen a couple raise hands function in this Zoom meeting. Also, I did not introduce myself. So real quick, I'm Jacqueline. I'm one of the advisors. I use she and her pronouns. I'll just note, since I'm seeing some raise hands, we will have a student panel and lots of time for questions toward the end. So hold on to your questions if you got them. And with that, now we will pass to Professor Hopper. We'll talk more about computer science. I'm just kidding. First, we have a poll. Okay, there's a bunch of students here, so I'm really curious about this in particular. We are asking, what inspires you most about computer and/or data science? The student panelists who are here and the faculty members can also do this poll. So these are the options that you have to choose from. We'll launch the poll. Would love to see what y'all find inspiring about these fields. Give a few moments here. Heard from just about everybody. We've got a few more coming in. Awesome. Okay, I will end the poll for now. Briefly share these results. I do always like to see these. We've got a pretty even split. We've got getting to solve and design complex problems, exploring innovative technical solutions, and interdisciplinarity. So, as you'll learn more about in a moment, computer and data science involve and are connected to many other fields of study, and then some others as well. But awesome. Thank you for your participation in that. And now, Professor Hopper, thank you for your patience. Let's talk more about computer science.
Sure. So I guess, one of the things you came to this meeting is to learn a little bit more about what's involved in getting a computer science BS degree. So let's talk about what you would study. Right, so the Association for Computing Machinery, it's a sort of professional society for computer scientists, has this definition of what is computer science. It's the study of algorithms, including formal and mathematical properties, hardware realizations, software realizations, and applications. What's an algorithm? Maybe you learned about this already because the word is used a lot in the press these days, but it's a sort of a procedure that always allows you to solve a certain class of problems, right? And so that's what computer science is really all about. It's about not just solving one problem, whoops, we lost my slides, but about coming up with a procedure, a set of steps that you can follow that will allow you to solve many related problems, right? And I think, we're also in the computer science departments here, also interested in other things related to these algorithms, how computers affect and can allow us to interact with others as well. So just a little bit more broadly than just algorithms is how we define computer science. In terms of how does that translate to courses, there's sort of two things to talk about. We can go to the next slide now. The first is the core, right? So if you're a computer science major, BS or BA, everyone has to take the core courses. So we have some courses that start off teaching from the very beginning. If you've never learned about programming before, that's fine. You can take Computer Science 1113 or 1133, and you learn about programs. How do we design, implement programs to solve problems and algorithms? And then in that second course, 1913 or 1933, we'll learn a little bit more about the mathematics behind algorithms and some of the ways that we can structure our programs to be more efficient. And then there's a sort of three kind of separate ideas besides that. So one is we want to learn the mathematics behind algorithms and program analysis. And so we have three courses that you need to take for those. We have two courses which are about sort of computing systems. How do we design and deal with these large, complicated systems in a way that makes sense to us? Well, we have this kind of layered hierarchical approach that lets us deal with the complexity of these systems. And so there's two classes that deal with that way of sort of turning machines full of billions of transistors into things that we can program and interact with easily. And then finally, there are two courses that focus more on designing software. So Computer Science 2041 is about learning about different approaches to writing and managing programs. And Computer Science 3081W is this sort of really large software project. You work in a group of students, and over the course of a semester, you're going to build a much larger program than the kind of small example programs that you deal with earlier on in the curriculum. Okay, next slide. And then once you've built up that foundation of knowledge, kind of that's common to all fields of computer science, in our degree, we have kind of this idea of a track where you'll take a bunch of technical electives and you'll try to sort of sort them together into a theme that kind of lets you go into more depth in one of a variety of different areas. And so in the computer science department, we have sort of 6, 7, I can count, tracks that allow you to kind of explore some of the different ways that these ideas can be applied, or the different ways that they interact with other fields. So we've got robotics, computer systems, data-driven computing, human-centered computing, more about the theory behind programs, or software engineering, kind of development kind of focus. And so you can choose one or even sometimes two of these to put together to kind of finish out your degree and learn more about the depth of computer science besides the fundamentals.
Awesome. Okay, one more poll. So this one is not explicitly related to computer or data science, but if you could choose to be instantly great at any of the following skills / superpowers, which would you choose? So we've got a bunch of options. I will launch the second poll. Have at it. These responses come in so fast. This is visually exciting. Okay. Got a couple more. Okay, I'll end that poll. This is super interesting to me. Okay, we've got a bunch of students who are interested in time control, pausing it, slowing it down, speeding it up, etc. And then a handful of others interested kind of all across the board. If we had time, I would ask students what the other power was. Now is not that time. So maybe if you're a computer science major and I end up being your advisor, you can tell me what that superpower is. For now, we will continue and we will talk a bit more about data science. So I will hand it over to Professor Shrivastava.
Hi. So let's talk a little bit about data science. Now, towards one of the last slides that you saw before the poll, there were these different tracks in computer science. And one of them was called data-driven computing. And there was another one about software and data systems. Now, what has happened is that over the last, I'd say about 20 years or so, there's been everyone talks about it. It's almost, well, it's definitely a cliche that we are living in the middle of a data revolution. We have data literally everywhere, from your smartphones to laptops to anything and everything that you can imagine, to your Fitbit, to or wearable watches. Maybe you wear Apple. Any of these things that you're wearing or you're connected to, there's data everywhere. And you go and you go and buy things online. Data is being collected. So literally in all walks of life, data is being collected. And in addition to that, there's been a big advancement in being able to analyze all that data to make sense out of it, and as well as being able to take different kinds of actions for it, whether it is in the scientific setting, maybe in engineering or medical setting, or of course, all kinds of commercial setting. So that is what the data revolution is. Of course, it also has all kinds of negative things, as we have seen in elections and as we are hearing from Facebook. So there are lots of things going on, all aspects of it. So what that did was that it essentially created this whole field called data science, and this term was coined about I'd say roughly about 15-20 years ago in the industry, and the idea was that let us try. Professor Hopper referred to computer science as studying computational processes. That is, how do you take some input data and it gets transformed through some processes into something that is what you desire. But there's something about the nature of the data itself and what can be, how does it model some aspect of some application, some reality, and how you can analyze and so on. So that's the whole field of data science. So can you go to the next slide, please? So these are the different kinds of skills that you learn. One is more on the first one is more about okay, so let me read the definition. That is, how to build models from data that are statistically sound, meaningful, and actionable. Okay, so all of these are important. So statistically sound typically means that it's not just something random fluctuation that you're seeing. It actually is, if you do it, if you carry out experiments, maybe 100 times or 1,000 times, maybe 1,000,000 times, let us say if it says that it has an accuracy of 85%, it will turn out to be 800 to 850 times out of 1,000, right? Okay, meaningful means that it has some meaning from the perspective of where that data came from, right? That you can do something about it, and finally that it makes sense to actually take some action on that. Okay, so collecting data, handling large amounts of data, building models from it, understanding the errors and the impact. I gave an example of, let's say, 80 to 85% accuracy. In some cases, that level of accuracy is acceptable. For instance, if you're thinking about, well, think Amazon or any of these marketing, direct marketing companies, they send you a message. If there's a even a 10% chance that you will respond, that is way beyond what they're expecting. Okay. On the other hand, let us say if you're talking about having a model that is doing some kind of cancer screening, over there, you want your accuracies to be in the high 90%, like 95, 98, 99% or beyond. Otherwise, that can create a lot of scare. Okay. In fact, recently we have been talking about what is the accuracy of all these COVID tests. So that's another example. So understanding errors and their impact. And of course, there's a wide range of applications. Next slide, please. Okay. So what are the core courses here? Now, data science is definitely a very interdisciplinary field. The Bachelor's of Science program is over here that we have created. It is sort of led by the computer science department. We play a major role in it, but really is a collaboration between a number of departments, as you can see, mathematics, statistics, industrial system engineering. We should also have ECE here, and of course, also some experience in writing. And as you can see, there's some core computer science kind of things like algorithm, data structure, software development, because those are the things everyone needs to learn. But also mathematics, statistics, and also the AI machine learning behind data science. So what are the basic theory, the theories from mathematics, from statistics, and as well as AI machine learning that drive this whole field. And here's a listed bunch of different courses that you can take. Then, of course, there is the systems aspects. That is, especially because computer science is heavily involved. So we want our students to be able to handle large amounts of data. So let us say in realistic setting, data science has become most relevant with another sort of trend in data called big data, the big data revolution, which is collection of huge amounts of data. So now for that, you can't just do with Excel spreadsheets or sometimes even with like relational databases, but you have to go to things like Hadoop and those kind of big data systems, the kind of systems that are used by Yahoo or Google or Facebook and many, many other organizations. So you learn things like that. And then of course, finally, there's a senior project, because data science, being a multidisciplinary field, is also about how do you go ahead and take all these different skills that you have learned in all these different courses and put it together into solving a problem. And the problem could be coming from maybe it's some public data like about climate, about population, about healthcare policy, whatever it is, or it could be more specific to a particular internship or with a company that you work with, something like that. And the idea is to understand a particular problem, see how, look at the data from it, use all these different tools that you have learned, the techniques to come up with a model, being able to analyze its error, get to a satisfactory level, and finally, also being able to communicate the results to stakeholders. Because when you're working as a data scientist, very often you will interface a lot with the people who want to use the results of your model. And therefore, being able to tell the story appropriately is extremely important. Okay, it's not just let's say some code that you're writing and checking into a GitHub, and your task is done over there. No, it's also the part about being able to model something. I mean, being able to build a model and then be able to communicate what its impact is for the appropriate application. That's why we also require that a writing course be part of the core curriculum. Next slide, please. Okay, and then there are these, there are a whole bunch of upper division electives, and there's 18 credits of approved upper division electives. And there's, as you can see, from a whole bunch of different courses that are participating in the program, from mathematics, industrial engineering, electrical engineering, statistics, CSI, as well as, so these are the different kinds of courses that someone can take as part of this, these electives. Okay, next slide. I think we might be just done with this. Okay.
Yeah, thank you to all of the faculty members. Certainly, as hopefully is now evident, both of these major programs, both of these fields have a lot going on. When it comes to pursuing these majors here at the University of Minnesota, the rest of the time that we have, we will devote to a little bit of information from advising, which is now. And then we also have some current students who are here. We have a giant number of participants, which is super exciting. So we will do our best to address questions. I will first talk through some of the information on this slide very briefly. I actually want to start by just noting that if you haven't had a chance to already, and I certainly tell this to all of my advisees as well, going to the actual department website for any major programs that you are interested in, or minors for that matter, is going to be a great way to get information. A lot of times we hear from students who have seen like the one-stop course catalog or some other central university resources, and those are great ways to get information. But whenever possible, make sure you're also checking out actual department websites, because there can be much more in-depth and sometimes even much more up-to-date information on those department websites. So I would definitely encourage you to explore the computer science department website and the data science department website. On those same websites, some of the bullet points that are on this slide, talking just a bit about life beyond the classroom, which is part of why we have our current students here as well. So Mott's really highlighted in the beginning that computer science is everywhere. You can do virtually anything with computer science and with data science. It's very interdisciplinary. And so whether it's getting involved in student groups, we have a number of student groups that are affiliated with our departments or affiliated with the College of Science and Engineering, or student groups that students pursue as a way to just supplement what they're doing. So student groups, great way to get involved and meet people. Undergraduate research, there's a bunch of different opportunities for doing that. Studying abroad, we will often hear that computer science and data science are majors where you can't study abroad, and that is super not true. So it certainly takes careful planning, but know that that is an opportunity available to computer science and data science majors. Career Center has an exclamation mark on it. A lot of questions that y'all might have are what sorts of internship opportunities or future job opportunities are available to you. The folks who are here in this particular event, I as an academic advisor, our faculty members who are here, and then our student panelists can speak a little bit about careers and career opportunities and things that have been able to be done so far if students have had internships, etc. But I also always really encourage students to work with the folks in the CSE Career Center. You have access to the Career Center as soon as you are an admitted student, and even after you graduate for a full year. So the professionals in the Career Center have tons of information. They are in direct communication with employers a lot of the time. And so that can be a really great place to get information as well. And then relationships and connections, maybe a little cheesy, but it has been a pretty bananas last few semesters, last several months. And so certainly these are both rigorous majors, but we very much, we meaning the department as a whole, staff and faculty, want to make sure that you all feel healthy and safe and like you belong in computer science and in data science. So we try to emphasize relationships and connections as well. So there's a little spiel from the advising corner. So what I will do next, I'll go to the next slide here. As I've mentioned a few different times now, we do have 3 current students who are here in this Zoom event. I'll let them introduce themselves in a second. But then we'll just also say, so the rest of the time, let me check the time. We have a half-ish hour, which is great. So I know a couple questions have already showed up in the Q&A function in the Zoom. I'll say probably for efficiency's sake, if you have a question, you can put it in that Q&A box. I think unmuting and trying to catch human voices will maybe be a bit wigglier. So I will be going through and fielding questions to the student panelists. But again, if questions come up for you later, or if maybe you have a specific question or something that is personal to you, I will put in the chat to the whole event actually. So csiug@umn.edu is the email address that goes to the 4 undergraduate advisors. So I am one of 4 advisors, and you are welcome to send questions there as well if we don't get to them in the next half-ish hour. Phew, okay, with that, students, if you would like to introduce yourselves briefly, I will let y'all do that, and I am going to executive decision blind pick. Lucas, would you like to be first?
Yeah, sure. Okay, so I'm Lucas. I'm in my 3rd year here at the U. I'm actually an older returning student, so the last decade I've been working previously as an educator, both at the elementary and middle school level, but I actually returned back and decided to pursue computer science. And so far I've done an internship last summer. I worked with Caterpillar and worked with AWS. And I'm also an officer for the competitive programming club. So far I've been able to have a few different experiences that I think were really worthwhile. And I've just sort of enjoyed, I guess, being able to be part of here at the U. So, yep.
Awesome. Thanks. Dan, want to take it?
Sure. My name is Dan. I use he, him pronouns. I'm a senior in the program, should be graduating this spring. I've been doing half-time with the program for a few years now and have experience with doing QA and software development, as well as some light research with a couple of groups on campus here. I was working with the chemistry department actually a couple of years ago because they do some computational stuff there. And now I'm working in, I'm a TA this semester and doing some research around computer vision and natural language processing.
Awesome. All right, Namita.
Yeah, could you repeat the question again? I think I
Oh, we're just
heard like half of it.
Yeah, no worries. We are just introducing ourselves for now.
Oh, okay, awesome. My name is Namitha. I use she, her pronouns. I'm a 3rd year in the comp sci program, and I have decided to go on more of a bioinformatics with an emphasis in data science track. I've done a lot of research. I really enjoy it, and my hope is to eventually become a medical doctor, but I want to get my PhD in sort of medical tech and the testing and data analysis of that or something similar. So that's why I figured computer science would be a good start.
Excellent. Thank you all. So there are several questions in the Q&A box. So I'm seeing a bunch. I'm going to do my best also to kind of group similar questions together. But one theme that I'm seeing, student panelists, are some questions about double majoring and whether or not that's useful, or if there are maybe other ways to get like access to skills without necessarily pursuing a double major. If either of the 3 of you or any of the 3 of you have any thoughts on double majors or minors or skills in that direction, would love to hear from you if stuff comes up for that.
I can probably throw some stuff at that. So my recommendation for students, regardless of whether or not you're doing major or minors or how many of them altogether, make sure that you're not overburdening yourself, right? Like you make sure that you're doing good in the stuff that you're participating in and not, running off and having too many things to on your plate. But if you decide that doing a minor or double major is too much work for you, there are tons and tons of opportunities on campus to get involved with research groups that may not even be in your major, right? Like I mentioned, I had worked with a chemistry department for some research stuff there. The research I'm working on right now is focused in computer vision and natural language processing, which are very firmly in computer science. but they have tons of applications outside of that. Like the project that we're working on right now is going to be ideally like reading medical labels to see if we can help visually impaired folks identify their medications a little easier, or stuff like that. There's opportunities so far reaching in computer science that most labs will probably be, ecstatic to have somebody computer savvy that can help them with their data or help them process the information that they're getting in. So that's one thought.
Yeah.
I can definitely answer this. I'm taking a computational biology major while also being pre-med and being computer science computational biology minor with a comp sci major, and I'm also pre-med. I'm doing a lot. Bouncing off of what Dan said, any research project that I've been involved in, they love having computer science students because every single research project does involve a lot of data, and being computer science students, you'll know how to deal with data, you'll figure out how to manage it, sort through it, analyze it, and it's really helpful to do it in a research setting because that gives you a little more real world experience, and it shows you like the applications of what you're doing in class, which I really, really like. Another thing I would recommend is to join clubs that are like not really within like computer science, like not just within like what your major is focused on. If you want to if you're thinking about, oh, maybe I want to minor in this, like join a club that has an emphasis on the thing you want to minor or double major in, and see if that's something that really does interest you. And that's like, I feel like that's a good way to just kind of test that out.
Yeah, awesome. Oh, Lucas, anything you want to add? Go for it.
Oh gosh. Yeah, I guess I would say the few friends that I do have that are double majors, I know that sometimes they're pretty stressed out, I would say, with the amount of work that they have to do. So I would say if you're gonna maybe double major, hopefully you're entering in with either a significant amount of credits already, or there's a significant overlap between majors, or I don't know. I know some people do maybe more of a 5-year plan, but I would say just make sure that you, as Dan originally said, that try to do something. If you're going to do one thing, make sure you can at least do it well before you try to take on 2 things or more. So
Well said. I will briefly add from an advising perspective. I will sometimes joke with my students that if you find like a job description that interests you, and in the required qualifications, it lists like 4-year computer science degree plus 4-year math degree or 4-year stat degree or 4-year whatever, then I would love to see that job description. For the most part, I encourage students to pursue skills rather than necessarily getting stuck on what your particular major or minor program might be. But happy to continue to talk about that if there are additional questions there. I'm looking in the Q&A as well, and another theme that's coming up for sure is what research might look like. And I know, Namitha, you're involved in lots of research. Dan, you've talked about research as well. The specific question that is jumping out to me is what it might look like, or how to kind of get started with or pursue a research opportunity, and then how that might compare to like a traditional research lab, like if there's anything unique to pursuing a research opportunity as a computer science student.
I will say that, like I said, there's a couple of different opportunities that are jumping up in the front of my brain for research opportunities. I know the deadline was today, but something to keep in mind for next year and the following years. There's a program called Europe on campus, which actually gives students the opportunity to do a research project on their own and receive a grant for it. So something to kind of help you out, build your portfolio a little bit, gives you some opportunity to try out research. And correct me if I'm wrong, but I think you get assigned a faculty advisor with that as well.
So you can be assigned an advisor, or if you already have an advisor in mind and you know that faculty member, then you can just kind of join the program together as well.
Yeah, so you get to work directly with a faculty advisor. Once you're in the program for a while and you're looking for your credits to finish out, there's also opportunities for you to work directly with a faculty advisor or research group that's on campus. And that involves reaching out to a professor and asking them about like, hey, can I work on some projects that you might have going on in your lab? And it's going to be different for every single one of those faculty members. It depends on what they're working on, and whatnot. So if you find a faculty member that is working in kind of a niche area that you find interesting, it doesn't hurt to reach out and ask, even if like, hey, can I just sit in on some of your meetings and hear about the projects? Like, that's kind of how I got us started with my current one, is they invited me to sit on some of their group meetings and listen to some of the projects that were available and were any of them interesting. And then, yeah.
I would probably say that asking professors is really the way to go. Obviously, your first couple of years, you're not going to, well, some of you might have an idea of what you really, really want to do. I know that I really didn't until a couple semesters ago when I found like the bioinformatics track, and I was like looking at the classes for that. And then basically I just kind of reached out to a professor who was in that field, who had a lab and was doing research I was interested in. And I just kind of went, hey, like, would you take on an undergraduate student? And that's basically how I kind of did that. I also did a UROP. So the UROP is a really, really good way to get research in. Especially if you like don't really know what you want to do, it's very easy to get assigned an advisor who meets a student and then work with them. And it gives you like a good connection too.
I guess I would say the research I did was a while, like 10, 12 years ago, when I was in the ChemE track. And I know that I definitely had a positive experience doing that. I think originally I sort of emailed a few professors and got to meet up with them, included like a resume and stuff. I think that like if you look on some of the professor bio websites, from what I heard from someone else, that sometimes they have a preferred way of reaching out to them. So I think that might be an avenue for if you are interested in research. I guess one thing, I know I saw one of the questions talked about like clubs, student organizations, and other stuff like that. One thing that I guess I'm a CA, so I'm a community advisor, and I know that when I was talking with a digital talent manager at the company I interned at last summer, they had mentioned that they looked on positively, like if you're RACA. So I think there's other things that you can do, work, I guess, whether through work or like student groups, ACM, ACMW. I know I'm part of the competitive programming club. So doing those sorts of, I guess, activities that might help you to prepare for like a technical interview or resume preparation and other networking events. I think that some of those other clubs that I tend to host, like ACM and ACMW.
Beautifully said. Yes, all three of you. Oh, go ahead, Dan.
I did just remember that I can't remember if it's the department email or if it's the computer science specific email, but there's an email list that occasionally professors will request to pay students to either participate in their research or help them do their research. So some of those are really good opportunities as well, because sometimes you'll get paid to do those things. Whereas some of the other opportunities, like I said, when you reach out directly to a faculty member to just work on their project and don't necessarily get paid for it, it's a great opportunity. Still do it if you have the availability to do it. But yeah, some of those opportunities are paid too.
Yes, read my mind. Great reason to sign up for the mailer, which I mentioned in the very beginning. Because there were so many research questions and it's such a popular thing to talk about, I'll actually too just ask if any of the three faculty members have anything that they think would be useful to add as far as undergraduate students pursuing research opportunities, tips or tricks.
I can say something real quick, Mats here. No, I think the advice was really good. We don't, and we're thinking about what we could do to help pair up undergrads with research opportunities. But right now, the best bet is to look at faculty web pages and see what seems to be interesting. learn a little bit about what that faculty member is doing. I get emails frequently says, I want to be involved in research. And then I mail back and says, what are you interested in? And they have no idea, right? It's sort of a blast to a lot of faculty members, hoping that somebody's going to bite on it. That generally doesn't work, right? Read up a little bit on what they're doing. You might not understand all of it, but at least you get the gist of it. And then reach out. And don't be surprised if some of them would want you to get a little more background in computer science. Some areas you can get involved in research fairly quickly with programming skills. Other areas might necessitate quite a bit of background. So it varies, but reach out to people. We're not scary. Well, some faculty might be a little scary, but most of us are not particularly scary. And we don't mind at all talking to people. And take faculty's classes. You take a class in graphics or virtual reality or bioinformatics or something else. Talk to the professors if you're interested in it and see what the opportunities are, right? There are all kinds of opportunities. It's just a matter of networking, reaching out, and being a little proactive.
Excellent. Somewhat relatedly, there was a question in the Q&A too, and I would love to hear from the students. If there were interesting or particularly useful elective courses, or like a favorite course that you have taken in computer science so far that you would maybe recommend. No cool courses. Okay, go Lucas, go.
Okay. All right, I'll go with I took although it was so much work, oh my gosh, 2021 machine architecture. I think was really interesting learning about the topic. But I think one thing that also was awesome was the Professor Kaufman was just as far as his detail, is very detail oriented, and in terms of the amount of I think effort and attention to detail that he would put into the curriculum, and making sure that students got what they needed, and even the ways that TAs in the class went out of their way to hold extra office hours and stuff like that, so we could get through some of the longer projects that were I think more difficult. So I think holistically I enjoyed the subject, but I also appreciated what the professor and the TAs did to get us through that. So yep.
So I'm taking CSI 3003 right now, which is Introduction to Computing and Biology. And I'm really, really enjoying this class. We talk a lot about like genomes and stuff like that. And I'm having a lot of fun kind of manipulating genomes, finding out where certain parts of cells have like changed to create like a cancerous cell and stuff. That's what we're really focusing on. I haven't taken this class yet, but I'm really looking forward to personal microbiome analysis, because in that one we get to, I think, just analyze some of our own genome and stuff, and I'm looking forward to that a lot.
Some of my favorite courses that I've taken so far that are, honestly, a lot of the electives ones are some of my favorites. We have I think somebody had mentioned a graphics, programming games and graphics one. That's, I think it's 4611. That was really fun. That one I know is a high demand class. If you're looking for something a little bit more interdisciplinary, there is 5115, I think, is the human computer interaction one, where you build an app, but you do basically a little research project and build an app around that, an Android app. That was fun. We have two AI classes, AI 1 and AI 2, which are really neat. You get to see a lot of cool examples of how we implement AI right now. And depending on the professor you take, there's also research opportunity, little small research project opportunities woven in those. As far as like main curriculum stuff, there's 381W, which is probably going to be your first exposure to working in a group and building an application, or working on somebody else's code to build something functional and to improve the existing functions of an app that's already out there. It's a basic C++ app, but it's still cool. It's like a little Photoshop. application. And it's cool to see how all those how Photoshop might actually handle some of the color math that goes in. So yeah.
Awesome. Y'all could be advisors. That was great. Another kind of interesting question, and I would be I'm curious for all of these, shocking, I'm sure. But one of the questions that popped up was how students can get involved with computer science early if they're still beginners. And some other questions, and just kind of a common question we often hear from prospective students is if they can succeed in computer science, if maybe they've never done programming before, or if they're new to coding and programming. And I know all three of these student panelists have a variety of backgrounds and experiences. So any of you are welcome to speak to kind of that topic, right? If we're brand new to computer science, can we still pursue this as a field and goal?
So I started my computer science, I guess, education when I was almost 20. So I had already gone through an entire year of education thinking that I was going to do psychology. So not even in a STEM, like a strong STEM field. I had planned to do psychology and took a basically computing 101 course over the summer to kind of fill out some extra credits, and loved it and never looked back. So yes, for sure. Some level of math proficiency is helpful, but I don't think that it's going to be too much. I think I saw a question earlier that was like, how much math do we use? I think you go through Calc 1, Calc 2, and then a stats class. You can do more math if you want, and the more math you know is going to be more helpful, but those are, as far as I remember, the requirements for CSI.
Yeah, I think for me, I sort of probably had the same fears that Dan had expressed. I think I was coming back to college as a 30-year-old after working for 10 years with middle school students, and I was like, dear Lord, what am I gonna get thrown out right away? But luckily I didn't. I think one thing that I did was I tried like Udemy. I was like looking on online courses even before the semester started. So I think by sort of going out of your way to sort of try to teach yourself, learn stuff, start coding, even if it's your own like personal project or a good tutorial, Coursera or something like that. And I think I found that helpful. I would even like Google like course materials for classes in anticipation of them, and then try to like go through tests and other stuff like that. So I think that sort of gave me sort of at least more of a sense of confidence going into these classes. But there were times where you're sitting next to someone and they've been coding for like 5 years, 8 years, and both of their parents like are like software engineers. And so I think sometimes it's finding different resources to sort of help yourself be successful, and give yourself the confidence that you need to know that you can do it. But yeah.
As Lucas just mentioned, I am that person who had 2 software engineering software parents and had been coding for like 5 years before I showed up to college. I will say though, I was coding in the base 2 languages that we use here. At least like when you start off, like Python and Java, those are the 2 languages that I was coding in, and I really liked those. And then as you get more into like those upper level classes, like C, OCaml, and just like C++, all those kinds of languages, I wasn't very comfortable with. So what I did was I went just before, like once I signed up for a class, I would go through and I'd look to see which language we were going to program in. And then I would just find the base structure. So like all like the for loops and like how to write a function, how to write certain things. I just go through and find like the very basic things that you should know how to do in a language. And like that will probably get taught within like the first couple weeks. And I just kind of made myself practice those things. And I found that that really helped to build a good structure for the language. So I could build off of that after the first couple weeks were over, because then I wasn't like, lost on like the basic things and I could move past.
Awesome.
Yeah,
Yes.
no, so Mats here, just a quick one on this whole thing. So the curriculum is really set up for you to be able to join without having any computing background whatsoever. So if you're interested, sign up for 1133, sign up for, what number is it? 1135, which is a bit of a companion course to 1133, where students can get together with faculty and discuss assignments and programming and other kinds of things, which has turned out to be extraordinarily helpful to get beginners up to speed. And you should have no problems whatsoever. You've been admitted to CSE, to the college. You're going to have no problems if you want to become a computer scientist. It's just a matter of diving right in.
Excellent. Yes. I know we have just 2 minutes left. And certainly, I mean, again, there have been many questions in the Q&A. I think a handful of folks, myself included, have been trying to privately answer the questions for those that make sense. I'll say kind of one more time, so that csiug@umn.edu email address that I put into the chat, that gets to the advisors. You are welcome to schedule appointments with advisors. The faculty members who are here are able to be emailed as well. Lots of questions about, you know, how to get involved with opportunities or pursue future goals. That's certainly a huge part of the profession of advising. So you are welcome to engage with us on those questions. I think in the 60 seconds that we have left, so students, I'll have you do lightning. There was one question that I loved that I would love your takes on, and that is the future of computer science. If in one sentence you had to describe what you think the future of computer science is or could be, what would you say? Ready, go.
We're going to build software that takes away all our jobs.
Artificial intelligence.
Yeah, I mean, computer science is going to be the core of basically every industry soon. And AI, everybody's worried about AI taking all the jobs. We are so far away from that. There's going to be such a need for us to kind of develop the strong AI that all these industries are looking for. So I just feel like it's just going to boom. There's going to be computer scientists everywhere. So you're not going to, these skills are not going to go to waste for sure.
I must point out that predicting the future is very hard. If you go, in fact, you can probably go and look up in 1997, which was the 50th anniversary of the ACM. They actually had a special issue where they went to some of the top people and said, okay, 50 years from now, or in the next 50 years, which are going to be the most important technologies in computing? Most interesting thing is that internet was not mentioned as one of them. So, or some of these things that are, smartphones and stuff like that were not mentioned as one of those 50 technologies, which have fundamentally changed the way, we live our lives today. So it's sometimes, predictions are hard to make. But I mean, some of the nearer terms are quite true, but what will happen in 30, 40 years is very difficult.
Indeed, indeed. All right. Well, we are at 5:01, which is fantastic. Many thanks to everyone for tuning in, joining in, however webinars work. Please direct future questions to us here at the department. Check out our department website. Big gopher round of applause to our student panelists. Thank you so much for your time and your insights. Faculty as well, y'all are the best. Have a gorgeous week, everyone.